All right, hey there, Longhorns. It's Miss Campbell, and today we're going to cover dimensional changes for 2D and 3D shapes. All right, so dimensional changes. That means we're going to be changing the dimensions or the side lengths of our figure. And so when you do that, your area and your volume change as well. Okay, so we're going to first look here. It says we've got our key concept is if the scale factor of two similar solids is A to B, then the ratio of their corresponding areas is going to be A squared to B squared, and the ratio of their volumes is going to be A cubed to B cubed. Now think about that. Why would it be, for area, why would it be squared? Well, think about the units on area. They're inches squared, centimeters squared. Everything gets squared with volume, or with area, I'm sorry. And then now think about volume, okay? It's A cubed to B cubed. Well, think about the units on volume. It's going to be inches cubed, centimeters cubed. Everything is cubed, okay? So the area and the volume, they don't just change like, you know, they don't become twice the size or 3 times the size. You're actually changing, area changes with the square of the scale factor, that's why it's squared, and volume changes with the cube of the scale factor, so that's why it's cubed. So we're going to go here and we're going to look at this first one. It says, how are the surface area and volume of the cylinder affected if all dimensions of the cylinder are multiplied by 3? So that means our radius is going to get multiplied by 3 and our height is going to get multiplied by 3 because we need radius and height to find the surface area and the volume, right? So here, my radius right now is 10 and my height is going to be 20. So let's look at the surface area for that. Okay, we're going to do 2 times pi times my radius, which is 10, times the height, which is 20, plus 2 times pi times the radius squared, so 10 squared. And y'all, I'm just using the formula for surface area. So we're going to plug this into our calculator. 2 pi times 10 times 20 plus parentheses 2 times pi times 10 squared. And so this is going to give us 1884.96, okay? 1884.96. And then we're going to calculate the volume. Okay, the volume for a cylinder is pi times the radius squared, so 10 squared, times our height, which is 20. So pi times 10 squared times 20. And so that's 6,283.19. Okay, so that's our original. Now let's go and see about changing our dimensions. We're going to make our dimensions 3 times the size. So our radius would now be 30, and then our height would now be 60, because 10 times 3 is 30 and 20 times 3 is 60. So we're going to calculate the surface area again. And instead of 10 for my radius, I'm going to do 30. And instead of 20 for my height, I'm doing 60. Okay, and we can already see it's going to be much bigger. Like, look, you got 30 squared versus 10 squared in here. So it's going to be much, much bigger. So I'm just going to type this in. Okay, and I'm going to get 16,964.6. And then we'll do the volume as well. Pi times 30 squared times 60. So pi times 30 squared times 60, and that is 169,646. Okay, and so now we're going to actually compare. We're going to divide. We're going to take our new volume and we're going to divide it by our old one to figure out how many times bigger. And we're doing the same thing with surface area. So we're doing new divided by old, and we're going to look at that. New over old. So I'm going to do the surface area first. Okay, my new surface area was 16964.6, and my old one was 1884.96. Okay, we'll divide that. And you will get 9. Okay, now we'll do the volumes. So look at that. We multiplied our dimensions by 3, right? We'll look at our volume. Our surface area. Our surface area was 9 times as much, not just 3 times as much, right? So now let's look at that volume. Our new one was 169646, and our old one was 6283.19. Okay. And when you divide that, you get 27. So our new volume is 27 times the old volume. So look at that, 9 and 27. What relation would that have to 3? Well, let's think about it. We said our surface area is going to change with the square of that scale factor, right? And then the volume is going to change with the cube of it. Well, our scale factor, we're scaling it up by 3 times, right? So think about that. 9, isn't that 3 squared? Yeah. What about volume? What would I do to 3 to get 27? Well, I'd have to do 3 cubed, because 3 cubed is 3 times 3 times 3. So you think about it. When you multiply the dimensions for volume, you're doing it in 3 dimensions. You're increasing it 3 times in the length, the width, and the height. And then for surface area, okay, it's going to be 3 squared, so 3 times 3. Area is 2-dimensional, so you're multiplying 3 in one direction and then 3 in another direction. So that's why area changes with the square of the scale factor and volume is changing with the cube of that scale factor. So you can see, it's not just times 3 whenever you're changing the dimensions. Your area and your volume are affected much differently. So now we're going to go on to our next slide. Okay. And we're going to actually determine if these figures here are similar, and then what is their similarity ratio from large to small, and what is the ratio of their areas and of their volume. So to determine if they're similar, it's just like we did with similar figures, we need to see if they are proportional. So we're going to compare the radiuses, and we're going to compare the heights, and we're going to see if they come out to be the same fraction. So I'm going to do large to small. So my radii, my large one is 6, my small one is 5. Okay, I can't reduce that anymore. So my radius, they are in a ratio of 6 to 5. Now I'm going to look at the heights. Again, I'm doing large over small. I have 12 over 10. And 12 and 10 you can divide by 2, and you're going to get 6 to 5. So look at that. That's your heights. Are your radii and the heights in the same ratio? Yeah, 6 to 5, 6 to 5. So these are similar, okay? They are similar because they have the equal ratios. Now they want the similarity ratio, aka the scale factor. Okay, it's a C, scale factor. And basically, you see how it says from large to small? You want large on top, small on bottom. Whichever one they're going from is going on top, to is going on the bottom. So my similarity ratio would be, you just use one dimension there, like either the radius or the height. We'll just do the radius because they're already reduced. It would be 6 to 5, or you can write it as a ratio. This is how you're going to commonly see it, 6 to 5. Whatever goes in the top goes on the left, whatever's on the bottom is on the right. So 6 to 5. All right. And then now they want us to know the ratio of their areas and of their volumes. Well, remember, your dimensions are just A to B, right? A to B. So we have 6 to 5. Your areas okay, would be A squared to B squared. That's their ratio. So we have 6 squared to 5 squared. So 36 compared to 25. Okay, and then the volume, the ratios of the volumes are A cubed to B cubed. So 6 cubed to 5 cubed. And so 6 cubed, you're going to do 6 times 6 times 6. And you will get 216. And then 5 cubed is 5 times 5 times 5, so it's 125. All right, so that would be the ratio of their areas and the ratio of their volumes. All right, and then their similarity ratio is 6 to 5. Okay, so now we're going to use our scale factor here, or we're going to figure out the scale factor when we're given the volume of 2 shapes. Okay, so we have to remember here, volumes, right? If I do the volume, and it says from the small to the large, so we have to do small over large, okay? So if I do the volume of the small one over the volume of the large one, they're going to be in a ratio of A cubed to B cubed because our volumes are always with cubed, okay? So we're going to plug in things here that we know. Well, I know the volume of the small one is 729. And I know the volume of the large one is 1331. And that's going to be A cubed to B cubed. Okay, so now what I want you to do, and I'm going to show you with the TI calculator. So I've sent you some information on how to download that. Please, if you don't have it, you can use it because you're going to need it for these. Unless you can use a scientific one, but it's going to be a little bit difficult or a little bit different. I'm not going to be able to show you all the steps on it, okay? Because our calculators just do it automatically. And so first thing you want to do is you need to reduce this, okay? We want to reduce. We need to get it to the simplest form, okay? A cubed to B cubed is still going to stay. So now what we need to do, I'm going to put 729 over 1331. I'm going to type that into my calculator, and so I'll bring it up here. 729 divided by 1331. Okay, enter. I can see I can't reduce it. So it's going to have to stay like this, right? So now, do I want A cubed to B cubed? No, I want A to B. So I have to take the cube root. All right, I have to take the cube root so I can get just A to B. So we're going to do, it's like a square root, but here we're going to put a 3. Okay, so it's the cube root, and you're doing it on both sides to the top and the bottom, okay? So when I do this A cubed, if I do the cube root, I'm just going to get A. And B cubed, if I do the cubed root, I'm just going to get B. And so now I'm going to calculate this. To do the cube root on the calculator, you're going to press the control button and then the caret key. Okay, control and then caret key. And now you can see it's got a little box here, and I want the cube root, so I'm going to do 3 in there. And then on the inside, I'm going to do the top one, so 729. And I press enter, and that's 9. Okay, and then now I'm going to do the cube root of 1331. So again, control, caret, cube root, so I put 3, and then I want 1331. And I press enter, and it's 11. So the scale factor here, the similarity ratio, is going to be 9/11, okay, or 9 to 11. So you'll see it phrased both ways. So that means that when I have my shapes, their sides are going to be in a ratio of 9 to 11. Alrighty, let's go to our next problem. Whenever we're solving problems, you need to get down to A to B first. You need to get that ratio first. All right, here we go. Okay, it says the volumes of two similar solids are 128 meters cubed and 250 meters cubed. The surface area of the larger solid is 250 meters squared. What is the surface area of the smaller solid? Okay, so first thing we need to do is we need to get our ratio A to B, because we always have to go, you need to go volume, you need to get to A to B, and then for your surface area, you're going to get A squared to B squared. And you get your surface area. So that's like the order we have to go. So volumes, they give us the small one and the big one. So I'm going to do small over large. Okay, so the volume of my smaller one is 128. And the volume of my bigger one is 250. And remember, that's A cubed to B cubed. So first thing I need to check is, can I reduce 128 and 250? So I will type it in my calculator. 128 divided by 250, and it's going to reduce it for me. It's going to be 64 over 125. So 64 over 125. That's still A cubed to B cubed, right? Now I need to take the cube root because I just want A to B. So I need to do the cube root here of everything. Okay. And in the calculator, you can actually do this as one big thing. So I'm going to do control caret cube root. And now look, I'm taking the cube root of 64 over 125. So I'm going to type that in there, 64 divided by 125. Oh, hold on. Got to get actually inside the argument there. So 64 divided by 125 and press enter. And see the calculator is lovely and does it all for us. So A to B is going to be 4/5. So A to B, 4 to 5. So we have our ratio. Now we're going to go and we're going to realize, oh, okay, surface area, the ratio of their surface areas should be in a ratio of A squared to B squared. So we're going to do surface area of the small figure, because we're doing small over large, right? And then surface area of the large figure would be equal to A squared over B squared. And y'all, we know A and B, so we can figure out A squared and B squared. And then they told us the surface area of the large figure, right? They said the surface figure of the large one is 250. So now I'm going to fill in what I know. I need the surface area of the small one. I know the large one is 250. And then A squared, y'all, A is 4, so 4 squared. And B is 5, so it's going to be 5 squared. So 4 squared is 16, 5 squared is 25. And now we have a proportion. Guys, cross multiply divide. Do this cross product here, that cross product there. So 25 times the surface area of the small figure is equal to 250 times 16. So I'm going to multiply 250 times 16. Okay, that's 4,000. And then to get the surface area of the small, I'm going to divide by 25. So the surface area of my small figure, okay, just divide by 25, 160. Okay, there you go. So whenever we're doing this, we have to go from the either volume or area, whatever they give us. We got to do either, for volume, you're going to do the cube root. Okay, for area, you would do square root. So we can get down to A to B. All right, once we have A to B, we got to set up another proportion, and we have to determine, since I was finding area, I had to use A squared to B squared. If I was doing volume, I would do A cubed to B cubed, and then we just solve our proportion from there. So now let's go on to our next example. Okay, So painting. The lateral areas of two similar paint cans are 1019 centimeters squared and 425 centimeters squared. The volume of the smaller can is 1157 centimeters cubed. What is the volume of the larger can? All right, again, look. Here, I'm going to go with the order that they gave me. They gave me the large one and then the small one, so I'm going to do large over small. And they've given me surface area, okay? I know it says lateral area, but that's a form of surface area. So we're gonna do 1019 over 425. And since we're dealing with area, that would be A squared to B squared. And so now I'm gonna check this 1019 over 425. Can I reduce it? 1019 divided by 425. Okay, that's as simple as it gets. So I'm gonna have to leave it like this. So now what we need to do, okay, to prevent things from getting messy, we're gonna leave things as square roots, all right? So to get A and B, I have to get rid of that square, so I have to take the square root this time. So it's just our regular square root, okay? So square root of 1019 over the square root of 425, that is A to B. Okay, that is A to B. So now what we're going to do is we're going to take this ratio and we're going to use it to find the volume. And remember, we're doing large over small. They want to know the volume of the larger, so volume of the larger, and then the volume of the small one they told us is 1157. Now remember, your volumes are going to be in a ratio of A cubed to B cubed. So we need to do the square root of 1019. I know it's going to look weird. We have to put that in parentheses and cube that. And then the square root of 425. And again, cube that. So now I'm going to actually go through and we're going to multiply here and then we'll get our answer. So we're going to do our cross products. And again, I know this looks weird, but if your numbers don't simplify nicely, you got to leave the square roots because otherwise you're going to get a bunch of error in there. So we're going to do all that there, okay? The square root of 425 cubed times the volume of the large one is equal to 1157 times the square root of 1019 cubed. Okay, and again, I'm not putting anything in the calculator just yet because these square roots are going to be not nice numbers. So I need to get volume of the large one by itself first. I'm going to divide by this. 425 cubed, okay? Square root of 425 cubed. And so now these will cancel. So I'll just type this final thing in the calculator and get my final answer. So I'm going to go over here. I'm going to pull up my calculator. Okay, I'm going to do control divide so I can get my fractions set up. I'm going to put 1157 times, and then now see I need parentheses, okay, parentheses, and I'm going to put this square root, so control square root of 1019. I'm going to press the arrow key so I can get out of the square roots, and then I need to put it to the power, so I do the caret key of 3. And then now on the bottom, I need parentheses, control x squared for that square root, okay. Get out of the parentheses now, and then I want caret 3. And then we press enter. And so the volume of the large one would be 4,295.48, so 0.5. Okay, so y'all, that's all there is to it for dimensional change. Like I said, sometimes you're going to get a little bit of icky numbers like this. Don't worry about it too much on like tests and stuff like that. We're going to keep them nice and simple for you. So more like one of our other examples that we did up here with our nice simple numbers where you can actually reduce them and take those square roots or cube roots, okay? So this example here, the one with the volumes one, that's a perfect one to look at. If you have any questions, just ask your teacher, and I'll see you guys in the next one.